Okay guys, we're going to finally do the calculation here. I'm going to start with doing the first two parts, part 1 and 2. I'm going to calculate the heat transfer for the heating up of the ice and then the melting of the ice. Okay, so those are the first two parts I'm going to look at. This is the way the problem would look. Okay, we would have basically telling me that I have 30 grams of water going from negative 80 degrees Celsius to 150. Just keep in mind that if we're going through the 0 and the 100 degree mark, okay, whoops, wrong tool. If we're going through that 0 and 100 degree mark, there's going to be a phase change, and most students forget this. So if you start at the negative 80, you're going to go through 0, through 100, to get to 150. So keep in mind that you have to heat it, melt it, heat it, boil it, heat it again. So it's going to be a 5-stage problem. You want to think that through as you look through this temperature range. Okay. All right. So I'm going to do part 1, which would be just that heating of the ice. Now there's a change in temperature, as I said before. Whenever there's a change in temperature, you're going to use Q equals MC delta T. Okay. Keep in mind that at this temperature, we're going to have ice. Okay, it's really important to keep in mind that we have ice. So my initial temperature is negative 80 degrees Celsius. My final temperature is 0 degrees Celsius. Okay, so when I do this calculation, I'm going to plug in my mass, which is 30 grams, my specific heat. Now I got to remember that this is of ice. Now specific heat of H2O, and we refer to that as the liquid, is equal to 4.18 joules gram degrees Celsius. Okay, we've seen that before. Now we've got ice. Ice is a little bit different. Ice is going to have a different specific heat. The specific heat for ice is 2.09 joule gram degrees Celsius. And we're going to have another one for steam, which we're going to use up here when we get to this point. All right, and that one is going to be 1.84. These numbers vary a little bit depending on certain conditions and pressures, but for this class, these are the ones that we're going to use. Okay, so my calculation, I'm going to go ahead and plug in Q is equal to my mass, which is 30 grams of water. Specific heat, because we're dealing with the ice, I'm going to plug in here 2.09, make sure you got your decimal there, joule gram degrees Celsius. And my change in temperature is going to be final minus initial. So in this case, my change in temperature will be negative, 0, because it's my final, minus a minus 80. And this is important because what I'm going to do is the change in temperature is going to dictate the sign notation. Because I'm increasing the temperature, this will be positive. Okay, these are always positive. This is positive. My heat transfer is positive. The other important thing to look for is the units. Watch your units, because here, when I do this calculation, I'm going to end up with my answer in joules. In this case, for this part, I'm going to end up with 5,016 joules. Okay, so that's heat transfer for part 1. So that is just this portion right here. Let's get some right here. So I'm going from negative 80 to 0. That's what I just calculated right there. Okay, what I'm going to do in blue is going to be number 2, my phase change. Okay, so number 2, what I'm going to do now is I'm going to melt the ice. Now, that's supposed to say ice. I-C-E. Okay, the problem with the melting of the ice is that there is no change in temperature. If the change in temperature is equal to 0, because there's no change in temperature, this calculation would be 0. Q would be equal to 0. Now, obviously, we know that that's not. That there is a value from here to here, and that's what this is. This is the measurement of heat, and that's Q. So there is definitely some heat being added to ice. We know that if we're melting ice, we have to add heat. So to calculate this, what we're going to do is we're going to use calculate the heat transfer, what we're going to do is use the 30 grams of ice, and we're going to use something called heats of fusion. Heat of fusion is the amount of heat needed to melt. I think I already talked about this. Melt or boil water. In this case, we're going to melt it, and it's the heat fusion, which is the 6.01 kilojoules per mole of water. And this is again per mole of water, so therefore what I have to do is get rid of my 18.02 grams of water, convert that to 1 mole of water. What I'm going to do is use the next value, which is 6.01 kilojoules for every 1 mole. This is nothing more than a thermochemical equation where I didn't write out the equation. I did it on the previous slide, in the introduction. If you want to go back and look at that, you can kind of see what the equation was. And I'm using a positive value because I am adding heat to the ice. This would be an endothermic process. If I were if I were to freeze the water back into ice, then I would turn this into a negative. So the fusion part would be negative technically. So when I do this calculation, my answer comes out to be 10.00 kilojoules. Moles cancel, grams cancel, grams cancel. So my answer is 10 kilojoules. Okay, so that's part 2. Okay, so let's go back and let's look at the answers here, or put these answers right in my final calculations. What I have to do is I have to get all 5 of these calculated. My first one was 5,016, and that was in joules. If you're not being careful with the units, you're going to run into some trouble here. So this was 10 kilojoules. So obviously my units aren't going to match, and I'm going to want to convert this to 5.02 kilojoules just to make my units match. Obviously, if you notice, I'm getting more heat added to the phase change than I am for the heating and cooling of the substance. So let's just take a look at that real quick here. Notice that this tends to be greater than, again, it depends on the change in temperature, of course, but for the most part, this tends to be most of the energy is being put into the phase change, and then it is the heating and the cooling of it. Okay, so that ends this tutorial. I did those first 2 values there. What I'll do is the next 2, and then I'll do a final version with the a wrap up of, I might try to do all 3 of these in one calculation, or in one video. So we'll see. I'll try to get that to you soon. Thanks.